The extreme value theorem had as part of the hypotheses that the function was continuous and that the interval was closed. And so then the natural questions would be, well, what happens if f is not continuous, and what happens if the interval is not closed? And so we want to take just a minute to look and see what such functions might look like. And so, for example, if we're looking at a function that's not continuous, let's take one that has a vertical asymptote. This is the function f of x equals 1 over x. We can write it out nicely. It's a really the simplest sort of rational function with a vertical asymptote that we can get here. And so we see that it is not continuous at 0. And so what happens is if this interval AB includes 0 in any way, we're going to run into trouble. And so depending on whether we are talking about it including 0 possibly at an endpoint, or and so that endpoint could be either the left endpoint or the right endpoint, or perhaps it's right there in the middle, then we've got different things that are happening. At 0, 1, for our interval, we see that we've got the upward arrow that's going to positive infinity because f of x approaches positive infinity from the right. So when our interval has 0 as the left endpoint, and we're really looking at only to the right of that vertical asymptote, we're going to have no max. And likewise for the left, instead of looking at the and including the arrow that goes up to positive infinity, we're including the arrow that goes down to negative infinity, because 0 would be our right endpoint, meaning the interval -1 to 0 would be coming in from the left, and so we would have no min, because the function trails off down to negative infinity. And then here, if we include 0 to where we're looking at both the left and the right, we have both the negative infinity arrow and the positive infinity arrow at the vertical asymptote, and so we don't have a max or a min. And so that's just an example where a discontinuity, depending on what your closed interval around it would be, you could get all kinds of scenarios here. Another sort of thing that could happen would be like a hole at an important place, for instance. Like if we had a function here that would have had a min, but instead of a min, we put a hole there, then that's going to cause our problem. So we have no min because the candidate for the min got removed. So I guess I'll say no min if the interval contains x equals 0. If it doesn't contain the discontinuity, then we are back into it being a continuous function on the interval. It could be discontinuous outside of it, but if we're looking at continuous when we restrict our vision, then we would have the max or min. But if that problem place is in there, for this particular picture, we're not going to have a max or a min. So the next sort of thing we might want to look at is what happens if the interval's not closed. So basically we're missing an endpoint. And so you could exploit that endpoint not being there in this sort of way. Like perhaps you had a function here that if we're restricting to, let's say the interval here is AB, where we are not going to include the endpoint A, but maybe we would include B. So we'd have a solid dot here over at B, but we would not be including the endpoint there at A. Well, at A, we see that it would have been a max there if that point was in the interval that we were looking at, but since we've removed that point on the interval, we've removed our place where we were expecting a max, and so we would have no max because that place for the interval was removed. And so the answer here for this question is we're not guaranteed a global max or a global min if we remove the hypotheses of continuity for the function or closed for the interval. So not guaranteed. The max and the min. Now, there's a difference between saying not guaranteed and there isn't one. Not guaranteed means there might not be a max and there might not be a min, but it's still situational here. And so we could have functions that are not continuous, intervals that are not closed, that still achieve a maximum and a minimum value. It just means then that those problem places ended up not being candidates for our max and min that we then had to throw away. So keep in mind that if we don't have continuous and we don't have a closed interval, then we're going to have to assess what's happening at those problem spots so that we can see if that's where we would have had a max or a min, but now don't because we've got missing points.